Well, hello and welcome back. We're going to be talking about common acids today. And so let's get right into this lesson if we could. Let me try to hit the share button. So in a chemistry class, it's expected that you would be able to identify a substance as an acid or a base. And there's a few very common acids that I need you to memorize, their names and formulas and their everyday uses. And these are the ones that I will ask that you know. Sulfuric acid is H2SO4. And the main use of sulfuric acid that you would probably think about would be in a car battery. That's battery acid. Sulfuric acid happens to be the #1 selling chemical in the world. And the reason for that is because a lot of things require an acid. And we're going to learn in a little bit later that sulfuric acid is a strong acid. And it basically gives you double the amount of acid for the same cost. And that makes it a very useful acid. Nitric acid is another strong acid, I need you to know, HNO3. Nitric acid, you might recall from our reactions of copper lab, if you got nitric acid on your skin, it left small little brown spots on your skin as it denatured the protein in your skin. Nitric acid is used to make fertilizers and explosives, such as ammonium nitrate. Ammonium nitrate is both a fertilizer as well as an explosive. And so nitric acid is a very common acid as well. Phosphoric acid is not a strong, but a weak acid. It has the formula H3PO4. Where you would most commonly recognize phosphoric acid would be as a food flavoring additive. It's oftentimes added to dark colas like Coca-Cola or Pepsi to give it a little bit of a sour taste. The other thing that phosphoric acid is doing in a carbonated beverage is you have to remember you've got basically sugar water, which is a wonderful medium to grow bacteria. So the acid kills the bacteria in the pop that you're drinking. Hydrochloric acid is a strong acid, HCl, and the most common area you'd find that might be, well, your stomach. It helps to digest the food that we eat and break it down. Acetic acid is a weak acid, and it has the formula CH3COOH. It looks like somebody sneezing like that with the coronavirus, but we won't joke about such things. Acetic acid most commonly would be, you would find it as vinegar. Vinegar is anywhere from a 3 to 6% solution of acetic acid dissolved in water. And the last acid that I want you to know is called carbonic acid. It's another weak acid. It has the formula H2CO3. Carbonic acid, when put in water, will decompose and make carbon dioxide gas in water. It is how we carbonate beverages. Now, I haven't talked very much about what makes sulfuric and nitric and hydrochloric strong acids, while phosphoric acid, acetic acid, and carbonic are weak acids. It's just the way they are. Mother Nature wants and makes sulfuric acid to donate 2 protons, nitric acid 1 proton. Phosphoric acid will not readily give up 3 protons. Therefore, it's considered a weak acid. I've listed here lots of common acids with their names. If you remember the nomenclature, maybe you remember the ic and us system. And if you remember, ic always was 1 higher oxidation number, us was lower. I'm not going to go through nomenclature, so we can pretty much skip this slide. I want to show you how acids form. So here we have a proton, just a naked hydrogen ion with a positive charge, and that's going to be attracted to water because water is a polar molecule. When the proton attracts to the water, we can see that happen here. It's going to combine with the lone pair of electrons in the water. What we form is called the hydronium ion. Now that entire water molecule picks up a 1+ charge, so that in essence, a proton in water is a hydronium ion. Usually we'll say pH is the opposite log of H+, but what we really mean is pH is the opposite log of the H3O+. But because protons don't exist by themselves outside of water, we just sort of substitute one for the other. I want to give you a little background on a few of the main acids. Here's sulfuric acid. As I mentioned, sulfuric acid is going to be what's in your car battery. It's the most commonly produced chemical in the world. It outsells the next 5 chemicals by itself. It's used in basically all industries, from oil refining to metallurgy to the manufacture of fertilizers to the process of making paper and metals and dyes and detergents. It's just a very, very useful acid. In olden days, it would have had the name oil of vitriol. If you've ever looked at or been allowed to see concentrated sulfuric acid, it is extremely dense and has just a little bit of a color to it. So that oil of vitriol makes sense. A vitriolic personality is a very violent, mean personality. And if you got concentrated sulfuric acid on yourself, you'd be both mean, and you would understand why that acid is a little bit mean, the way it treats your body. So sulfuric acid can be a very dangerous acid in high concentrations. Nitric acid, another strong acid, HNO3, we mentioned can yellow your skin if you get it on your skin. And it's generally, we think of, used to make fertilizers and explosives, and there are other things I've listed here as well. An old name for nitric acid is aqua fortis. I mention these old names because sometimes students will read on the internet how to do different things, and they'll see these old names. I would very much recommend you do not follow any of those procedures you find online. Oftentimes they're written by people that don't quite know the chemistry, and they can be very dangerous to do. Hydrochloric acid, another strong acid here. HCl says it's stomach acid. Now I put on here a red ant. A red ant comes from the genus Murium, and in some cultures in olden days, they would catch these biting red ants and they would grind them up and boil their bodies to extract out what they would call muriatic acid, because it came from the red ant that came from the genus Murium. We now call muriatic acid, well, it's a form of hydrochloric acid. It's not very pure, that you can buy from a hardware store such as Home Depot. What is it used for? Well, if you pickle iron or steel, it's the way that you clean off the corrosion or the rust. You simply take a rusty bar of steel and you leave it in. It doesn't take very long, just 30 seconds or a minute, in concentrated acid, and it will dissolve all the impurities from off the outside of that metal. You can take it off, rinse it, dry it. You'll have a pristine, clean piece of iron or steel. That's what pickling in hydrochloric acid, that's what they're talking about. The other thing you might do with it is, let's say it's springtime and the summer's rolling around. You take the lid off your swimming pool, and you realize that the water is disgusting green algae everywhere in that swimming pool. Now, it would take a lot of water to replace it. So instead, you go to the hardware store, buy a gallon or 2 gallons of concentrated muriatic acid, and then you just simply pour that into your swimming pool, and it's called shock treatment. It kills the bacteria, kills the algae, and then you just have to adjust the pH to get it back to a comfortable pH to swim in. It's also used to clean concrete or masonry. With new construction, with poured concrete, concrete, remember I mentioned in an earlier lesson, is very basic, and things that are basic are like bars of soap. They're slippery. So if you were to try to paint freshly poured masonry or concrete, the paint will not, it might dry, but it won't really adhere to the concrete for any extended period of time. Within 5 years, it'll probably be peeling. So as a homeowner, what you want to do is buy some muriatic acid. There's a spray unit you can buy to pour it in, wearing safety glasses and protective gloves and so on. You can spray muriatic acid all over the brick and the concrete in your basement, and it will bubble and bubble. And what it's doing is neutralizing the base that's in the concrete. When it stops bubbling, then you'll have to hose off all that concrete. You probably use a shop vac to dry everything. Then you can put a piece of tape over the concrete overnight. If the next morning there's no moisture under the tape, the concrete is dry and it's been neutralized. And now when you paint it, that paint will stay on there for decades. So having a little bit of knowledge of chemistry can be sometimes very helpful. Now, on the bottom, I've shown you that HCl can be a gas, and when it's gas, It's a molecule, it's a binary molecule, and it would be called hydrogen chloride. But as soon as that hydrogen chloride gas is bubbled or dissolved into water, the name changes and it's now hydrochloric acid, and we use an AQ to indicate it's dissolved in water. Here are some common bases: sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide. Are you seeing a pattern here? Bases oftentimes end with the name hydroxide. Now the last one says ammonia water, but really ammonia water is ammonia gas dissolved in water, and we would call that something else. It would actually be ammonium hydroxide. So a hydroxide is an OH minus ion. Now when we look at these, all of them have that hydroxide. Sodium hydroxide is called lye, that's a common name for it, or caustic soda. It's the active ingredient in Drano. It actually, if you remember from the soap article, if you take sodium hydroxide and pour it into a solution of fat, it will saponify it, turning the fat into soap. And that's how soap is made. It's also how drain cleaner works. If you have hot fat that you pour down a drain and it cools and solidifies, you can pour water on that all day long, and the polar water will not penetrate the non-polar oil stop up in your drain. So instead, you buy some Drano, and that will saponify and clear the drain. Potassium hydroxide is what we use to make our soap. It's pronounced, I know it looks like potash, but it's pronounced potash. This is the byproduct of wood burning, and it's potassium hydroxide. Magnesium hydroxide is milk of magnesia. Perhaps you've heard of milk of magnesia. It's an antacid that you drink because you have an upset stomach with too much acid. They used to make a commercial for milk of magnesia, and they said, upset stomach, call MOM, call your mom. And then after it wrote mom on the screen, you would see the name milk of magnesia, MOM. Now, a competitor of milk of magnesia was one that was called Tums. And Tums used calcium hydroxide to neutralize the acid in your body. The OH, the hydroxide, is what's neutralizing your acid. The magnesium didn't really matter. So what Tums did is said, oh, your body needs calcium anyway, so why not take Tums instead? It was clever marketing. Another name for calcium hydroxide is slaked lime. It's one of the ingredients if you're making concrete, and the cement is slaked lime, and you add water, and it's going to undergo a chemical reaction to make the concrete. The last example, ammonia water, is actually ammonium hydroxide. What happens is the ammonium hydroxide, there's your ions, actually are going to be like NH3, ammonia gas, and water. And that's what happens if you take the lid off ammonia hydroxide, that green lid, and you waft it. Woo, that is strong. That's concentrated ammonia. Okay, they use concentrated ammonia like that, maybe at a hospital. If someone is unconscious on the bed or pretending to be unconscious, they'll take a little, it looks like a little pill, a little ampule. They'll break that open and they'll stick it under the patient's nose. And if they're truly unconscious, they won't respond. But if they're faking, they will wake up. Perhaps you've also seen it when a professional boxer gets knocked out. They're laid out cold. The doctor goes, opens up one, puts it under their nose, and immediately they wake up from that. So it's a very jarring smell of concentrated ammonia. All right, let's keep on moving here. Let's see what else we got here. I'm not going to go through conjugate acid base right now, so I'm going to skip all of this stuff with you for right now, and I'll just leave you with the idea that acids and bases produce salt plus water. This is called neutralization, as you remember. I'll give you some examples. If you take things with pretty large differences in pH, like orange juice, clearly an acid, and milk, it'll give you a bad taste. It produces a salt in your body. We mentioned earlier that if you have concrete, it has a lot of base in it, and if you water it, it's going to leach out some of that hydroxide. Evergreens love acid. They're one of the few acid-loving plants. So if you have new construction and plant some little evergreen trees next to the foundation of your house, the trees are probably going to die when it rains. It's not due to the fact that it's not getting enough water. It's due to the fact that every time you water it, the water hits the concrete and it turns the water basic, which is not good for those evergreens. The same thing happens if you put fertilizer, a base, on your yard and you put it under pine trees. Pine trees drop needles to acidify the soil underneath them. So if you were to add fertilizer thinking you want to grow grass under the pine tree, what you're going to end up doing is making a white powder, a type of salt that will kill the tree or plant. So you'll see this yellowing sometimes. That's called chlorosis when this happens on pine trees. And people's immediate effect is they think they need to add more water or more fertilizer, both which are going to cause more stress for the tree and potentially kill it. So at the bottom of the slide, I have an example of, what's the name of that acid, please? Good, hydrochloric acid. And what am I mixing it with? Sodium hydroxide. Good. Here's our acid because it has a proton. Here's our base because it's an OH. There's going to be a double replacement reaction where the sodium and hydrogen switch places. The sodium ends up with chlorine in this double replacement reaction, and the hydrogen ends up with the hydroxide making water. So every time we combine an acid and a base, we make a salt, that's a metal-nonmetal combination, in water. This is a double replacement reaction. The driving force here is the formation of water. We can look at this reaction in another way. We have here a hydronium ion. There's your H3O with a 1+ charge and a hydroxide. And you can imagine what's going to happen is the positive and negative are going to attract those ion charges. And what's going to happen is one of these protons is going to transfer over to the hydroxide. And in that process, we end up forming two water molecules. So we started with an acid and a base. So that was a hydronium and a hydroxide, and we end up with just water. Okay, I think that's about as far as we wanted to get today in terms of our discussion. So I'll go ahead and let me find how to close this guy off here. Stop our discussion. It's got to be close here. There we go. And so the lesson today hopefully made a little bit of sense. Watch it a second time if you need to. And please keep watching these videos and keep learning. Do your best.